Good morning, students. So in our last class, from the chapter Application of Derivatives, exercise 6.2 up to question number 8, we have completed. Is not it? So now here, the next one is the question number 9. So the question number 9 is given here. If you see the question here, the question is given here what? The function, whatever given here, this function we need to prove strictly increasing in the interval 0 to pi by 2. Is not it? The function is given here and we need to prove this one is strictly increasing. So this type of questions are actually asked in exam. These questions are very important examination point of view. So you have to see this one, how can we do this question. And one more thing here, the earlier questions whatever we have done already we complete. I think all of you understood these questions because there is no queries or no questions in my comment box. So that's why I hope all of you understood these questions. So after completing up to 8, question number 8, now we start now the next question, question number 9. Now the question is given here. The question is given in such a way that if you see here given, so given y equals to this one is given here for sine theta. That means this one we get here 4 sine theta divided by 2 plus cos theta. 2 plus cos theta minus of theta. This one is the question. So if you see here, the question is here 4 sine theta divided by 2 plus cos theta minus theta, isn't it? So this one is the question here given, and this question what you have to do here, we have to differentiate this question first with respect to here the angle is theta. So that means with respect to theta we have to differentiate this one first, and after that what you have to do, we have to find out the critical point or the value of theta. From here we have to find out, and let's check out the points when we put on the number line, or that means the interval whatever given, the interval is given how much here, from 0 to pi by 2, and we need to prove this one is increasing, isn't it? So now let's see here. First of all, if you differentiate this result, now differentiating this one with respect to theta, so that's why we have to write this one is dy by d theta. So dy by d theta equal to, if you differentiate this one, then we have to write here dd theta of this one we write 4 sine theta. So that means we have to write this one is 4 sine theta divided by 2 plus cos theta minus then dd theta of this one we have to write here dd theta of this one we write theta. Is it clear? Okay, now if you differentiate this one, now it is of the form u by v form. So if we apply u by v form, then we have to write 2 plus cos theta. So 2 plus cos theta whole square, and then what you have to do, we keep this 2 plus cos theta here, and 2 plus cos theta we keep here, and then we have to differentiate this one dd theta. So dd theta of this one we have to write 4 sine theta. Is it clear? Okay, after writing this one, now the next part is what you have to write. The second part, we keep this 4 sine theta, so minus 4 sine theta, so minus 4 sine theta, and then we have to write this one is dd theta of this part. This part is what? 2 plus cos theta. So that means we have to write this one is 2 plus cos theta. Is it clear? And then this one is the first part, and the next part is here dd theta of theta. That means this one we have to write here minus 1. Is it clear? So this one. So now after differentiating this one, now if we calculate this result, if you see the denominator is same, so that's why here we have to write 2 plus cos theta whole square. If you see here 2 plus cos theta whole square, now here in this case if you see here 4 is constant term come outside, and dd theta of sine theta means what? Cos theta. So that means we have to write this one is 2 plus cos theta, 2 plus cos theta into 4 cos theta. So 2 plus cos theta into 4 cos theta. Is it clear? Then next part we have to write here, this one is minus 4 sine theta. So that means we have to write this one is 4 sine theta, and dd theta of 2 constant term 0, dd theta of cos theta is what? Now in this case we get here minus sine theta, isn't it? dd theta of sine theta cos theta is what? Minus sine theta. So minus minus here what we write? Minus minus ultimately plus. So ultimately what we write here? Plus 4 sine square theta. I think all of you understood this one. 4 sine theta is here, and dd theta of this one. Or if you want, then you can write one more step, minus 4 sine theta, in bracket you have to write 0 minus sin theta. So here I directly calculate, and then here the result is what? Minus of 1. Is it clear? So this one is the result. So now here the next step is 2 plus cos theta whole square, and in numerator this one we get here 2 4s are 8. That means this one we have to write 8 cos theta, and plus of this one is cos square theta. That means this one we have to write 4 cos square theta, and already here present 4 sin square theta. So that means we have to write this one is 4 sin square theta, and this one is minus of 1. Is it clear? So now in this case, after getting this one, now if you see here, if we take LCM, before we take LCM, now here you see 4 is common. So if we take 4 common, then cos square theta plus sin square theta remain. Cos square theta plus sin square theta means 1. So ultimately we get here 2 plus of this one we write cos theta and whole square. This one is 8 cos theta, and plus of here 4 common. So that's why we just write 4 here. Is it clear? Then next one is here minus of 1. I think all of you understood this. Now after that what you have to do? You have to take LCM. So if we take LCM, now here the LCM is we get here 2 plus of cos theta whole square. So if we take LCM, then this one we get here 8 cos theta plus 4, and then after that this part we have to multiply with this result. Isn't that it? LCM. So if we directly break the result here, we multiply, and as well as we have to break this result, and then what we get here? Minus of, then in this case we have to write 4, 2 square, 4 plus cos square theta, a square plus b square, plus twice ab. Plus twice ab means what you have to write here? This one you have to write 2 to the 4 cos theta. So that means we have to write this one is 4 cos theta. I think all of you understood this one. Is that it? 8 cos theta plus 4 we have to write first, and then minus 1 we have to multiply this result, and then here if you break this result, 4 plus cos square theta plus 4 cos theta, that means a square plus b square plus twice ab we get here. Is it clear? So after this, we get, so here in denominator we have to write 2 plus cos theta whole square, and in numerator what you have to write? You see here plus 4 minus 4 cancel. Similarly cos theta is there, minus plus minus 4 cos theta. So 8 cos theta minus 4 cos theta, that means this one we get here 4 cos theta, and then minus plus minus we have to write this one is cos square theta. Is it clear? This one we get. Now from here if you see the next line we get here, this one is 2 plus of cos theta whole square. So this one we write 2 plus of cos theta whole square, and in numerator if you see what is common here, cos theta is common. So if you take cos theta common, then here remain 4 minus of cos theta. Is it clear? So dy d theta, so dy d theta value we get this one. So after differentiating with respect to theta, dy d theta value we get this one, cos theta into 4 minus cos theta divided by 2 plus cos theta whole square. Is it clear? Now after finding dy d theta, next what you have to do here? We have to find out the value of theta. And how can we find out the value of theta? So we have to consider dy d theta equals to 0. Is not it? So dy d theta, so that means we have to write here dy d theta equals to 0, or dy d theta value we know, dy d theta value is how much here? We have to write this one is 2 plus cos theta, 2 plus cos theta whole square, and in numerator we have to write this one is cos theta into 4 minus cos theta. Isn't it? So this one is the value equals to 0. Is it clear? Okay, now here if you see, if you cross multiply this one, so simply here remain cos theta 4 minus cos theta, 4 minus cos theta equals to 0. So if you cross multiply this one, then here remain cos theta into 4 minus cos theta equals to 0. So therefore what we write here, cos theta equals to 0, or in this case we get here 4 minus cos theta equals to 0. So now in this case you see it is not possible. Reason behind, if you see here cos theta equals to 4, it is not possible, impossible this one. Why? we have to write here not possible or impossible. This one we write not possible because the maximum value of cos is what? 1 and minimum is -1. So here the cos theta value is, we get here 4. It is not possible because the maximum value is 1. So here after that, if you see here cos theta equals to 0, is not it? So cos theta equals to 0, that means this one also we can write cos theta equals to cos pi by 2. Cos 90 0, is not it? So if cos 90 0, then from here what we get here, theta equals to, we get pi by 2. So that means the value of theta we get here. Theta equal to how much we get here? Theta equal to pi by 2 we get. Is it clear? So now after finding the value of theta here, next what you have to do? Now we have to check out the interval. The interval is given from 0 to pi by 2, and 0 to pi by 2 we need to prove it is increasing, isn't it? So in between these two we have to put this point here, 0 to pi by 2. So that means here you see theta equal to, ultimately here we get pi by 2, isn't it? Now if you see the next part here, now after getting the value of theta here, theta equal to how much we get here? Pi by 2. So that means next what you have to do, so the interval is given, interval is given from 0 to pi by 2. So 0 to pi by 2. If you see the interval from 0 to pi by 2, now here the result, this result we need as a whole, this result we have to need, we need cos theta 4 minus cos theta and 2 plus cos theta whole square. If we prove this whole result is greater than 0, that means if this result is greater than 0, so in place of what we can write, dy d theta we write, and dy d theta is also greater than 0 we can say here, is not it? So now first of all you see the given interval is given from 0 to pi by 2. If the given interval is given from 0 to pi by 2, now in this case you see 0 to pi by 2 means which quadrant? First quadrant. So if 0 to pi by 2 is the first quadrant, in first quadrant all trigonometric functions are what? Positive. So that means in this case if you see the first one cos theta, so in 0 to pi by 2, so we can directly say the value of cos theta is what? Greater than 0. Can we write here? Yes, obviously we can write this one. Why? This one is the first one. If we denote by 1 here, in interval 0 to pi by 2, each and every value, each and every trigonometric function is positive here. So that's why without doing anything we can directly say here cos theta value is greater than 0. Now the next part you see here, this one 4 minus cos theta. So this one also we can write directly here. Reason behind, if you see here 4 minus cos theta, the second one we have to write, this one is 4 minus cos theta is also greater than 0. You know the reason here, because the maximum value of cos is what? 1 and the minimum is -1. So if you take the maximum value, so maximum value of cos theta is 1. So if we put 1 here, 4 minus 1 ultimately what? 3 is greater than 0 or not? Yes. So that's why as a whole 4 minus cos theta is also greater than 0 we can write here. Is it clear? And finally the third one, if you see the third one is we need here 2 plus cos theta. So that means here 2 plus cos theta. So 2 plus cos theta whole square is given here. Now any value, if the value of cos theta is negative also, then here if as a whole the result is negative, but here this whole square, this negative result convert into positive result. So that's why this value is automatically greater than 0, is not it? So that means here if you see here all these three results are we get greater than 0. Why we find out separately? Because we need this result. So that's why we have to check out cos theta greater than 0, 4 minus cos theta greater than 0, as well as 2 plus cos theta whole square is also greater than 0. So we can write cos theta, then 4 minus of cos theta divided by 2 plus of cos theta whole square is greater than 0, is not it? You see here cos theta is greater than 0, this one is greater than 0, this one is greater than 0. As a whole, the whole result is what? Because all these three are positive, that means from here as a whole this result is greater than 0. If this result is greater than 0, from here what we can say here, dy d theta, the value of this result is what? Dy d theta. So dy d theta is greater than 0. So from here what we can say, the given function y is strictly increasing on which interval? 0 to pi by 2, is not it? So therefore what we have to write, the conclusion we have to write here, therefore y is strictly increasing. Therefore, we can directly write here y is strictly increasing. But in our question, we need to prove only increasing, not strictly increasing mentioned here, only increasing. Increasing means what? Greater than equals to. So how can we get the equal sign here? Here we prove only strictly increasing. So now let's see the increasing part here. So already mentioned there 0 to pi by 2. So 0 to pi by 2 interval. So now in this case we exclude 0 and pi by 2. So that's why we get strictly increasing, isn't it? So now here the endpoints are 0 and pi by 2. So if we put 0, here, now you see here cos theta, isn't it? So if we put 0 here cos theta, so in this case if you put this 0, then here we have cos 0, what we get? Cos 0 1, cos 0 1, cos 0 1. Ultimately what we get here? Ultimately we get here a greater than 0 value. Is it clear? 0 and pi by 2. So if we put in place of theta 0, then cos 0 here, cos 0, cos 0. Cos 0 1, so that means here remain 4. Ultimately if we calculate, then we get greater than 0 value. Is it clear? Next, if you put here pi by 2, now in place of pi by 2, if you put here cos pi by 2, what is the value of cos pi by 2? Cos pi by 2 0. So if we put cos pi by 2, then as a whole the whole result is what? Equals to 0. So here if we put these 2 points, here 0 and pi by 2 in 0, then greater than we get, and if we put pi by 2, then what we get here? Equal to 0. So greater than we get and equal to also we get. So that's why here from this condition what we can say, the conclusion we have to write, hence y is increasing in the interval. Which interval? 0 to pi by 2. 0 and pi by 2 both are including. So that means close interval. Is it clear? If we write open interval, then it is strictly increasing. Otherwise, if 0 to pi by 2 close interval if we write, then we have to write increasing. Is it clear? I think all of you understood this one. Now after completing the question number 9, now if you see the next question, question number 10, and the question number 10 is given what? The logarithmic function is strictly increasing on the interval 0 to infinity. So that means we have to consider here the function is not mentioned here, the function is mentioned as a logarithmic function. Is it clear? So the function we have to assume by our own logarithmic function. And then this logarithmic function is strictly increasing on 0 to infinity, we need to prove here. So very simple question here. So first of all what you have to do, if you consider the function, so if you consider a logarithmic function, so fx equal to, if we assume log x, now in this case you see fx equal to log x we assume. Now here if we differentiate this result, so f dash of x, so f dash of x equal to ddx of log x, we get 1 by x, isn't it? So now here the interval we need to prove from 0 to infinity, open interval. So now in this case one thing here you see, it is clear that x is not equal to 0, isn't it? So if x is equal to 0, 1 by 0 undefined we get, isn't it? So the value of x equal to 0 is not possible, first thing. And the second thing what we need the interval from 0 to infinity. If you see the interval here, the interval we need from 0 to infinity. So that means all positive values are we need. So here less than 0, the negative values are not possible because we need to prove from 0 to infinity. Only the positive values we need. And 0 is also not included here because if we put 0 then it is undefined. Is it clear? So that's why here one line we have to write here. It is clear that the value of x is not obviously greater than 0. It is clear that x is greater than 0 because all the results are we need here positive value. So that's why it is the value of x is greater than 0 we have to choose here. Otherwise if we choose 0 equal to 0 then it is undefined, and if you choose the value of x is less than 0 then we get here negative value, and negative values are not included under 0 to infinity, isn't it? So therefore if we choose positive values, that means greater than 0 value, if we put here 1 by 1, any value if you put, suppose if we put 2, if we put 3, if we put 4, any value if you put, then obviously the whole value is ultimately what we get, greater than 0 we get. So therefore without doing anything we can directly write f dash of x equal to 1 by x, and this value is obviously greater than 0. Why? Because the value of x is greater than 0. If value of x is greater than 0, that means if positive values are we put here, then as a whole 1 by x value is obviously a positive value. If 1 by x is a positive value, that means greater than 0. If greater than 0, that means we can write in this way. So here, from here, the conclusion we have to write f dash of x is greater than 0. So f dash of x is greater than 0 means this one is the condition of what? Strictly increasing, is not it? So this one is the condition of strictly increasing. So that's why what you have to write here, ultimately the final conclusion we have to write. Hence the given function fx is strictly increasing in the interval 0 to infinity. 0 is not included. If 0 included, then undefined, and infinity obviously open interval. So that's why we have to write here 0 to infinity. Is it clear? So here today we complete 2 questions. So more questions are remain there. So these questions are we have to complete in our next class. Is it clear? Okay. Thank you.